Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of object-oriented software engineering. We'll dive into key concepts like object-oriented testing, correctness and consistency of OOA and OOD models. Let's get started. Slide 1. Object-oriented testing. Welcome everyone. Today, we will discuss object-oriented testing, OOT, and how we ensure the correctness and consistency of object-oriented analysis, OOA, and object-oriented design, OOD, models. In traditional software testing, we focus on functions and procedures, but in object-oriented testing, the focus shifts to objects, classes, and their interactions. Since encapsulation, inheritance, and polymorphism are core concepts in object-oriented programming, we need specialized testing methods. Testing is performed at multiple levels. Class-level testing. We test individual classes to verify if they function as expected. Integration testing. We ensure that different objects communicate and interact correctly. System testing. We check if the entire software system functions as per the requirements. For example, in an ATM system, we test individual classes like account, transaction, and user, then move on to testing their interactions, and finally, we test the entire system. The significance of object-oriented testing is that it ensures our software remains reliable, reusable, and maintainable, which is crucial for large-scale systems. Slide 2. Approaches to object-oriented testing. Now, let's explore some of the key approaches used in object-oriented testing. 1. Unit testing. Involves testing individual methods and class behaviors in isolation. Example, in a student management system, testing whether a student class correctly updates the GPA when grades are entered. 2. Integration testing. Ensures that objects interact correctly when combined. Example, testing if a student object correctly registers for a course object and updates the enrollment count. 3. Regression testing. Ensures that new code changes do not break existing functionality. Example, adding a new feature in an e-commerce app and testing whether existing cart functionalities still work. 4. System testing. Tests the entire application as a whole to check if it meets user requirements. Example, testing whether a banking application allows seamless fund transfers, bill payments, and account management. 5. Acceptance testing. Performed from a user perspective to see if the software meets business needs. Example, a client verifying whether a newly developed payroll system meets all salary processing rules. 6. Mutation testing. Small faults, mutations, are introduced into the code to check if the test cases can catch errors. Example, deliberately altering a tax calculation function in payroll software to see if test cases detect the incorrect results. These techniques together ensure that object-oriented software is robust and performs reliably in real-world conditions. Slide 3. Correctness and consistency of OOA and OOD models. Now, let's talk about the correctness and consistency of object-oriented analysis, OOA, and object-oriented design, OOD, models. 1. Correctness means that our object-oriented design accurately represents the system's requirements without missing any functionality. 2. Consistency ensures that the design follows uniform rules and that objects interact logically without contradictions. To achieve correctness and consistency, we must check the following. Well-defined class responsibilities. Each class should have a clear role and should not take on multiple responsibilities. Example, in a library system, a book class should only store book details, while user should manage user information. Valid inheritance hierarchies. Child classes should only inherit relevant attributes and methods from parent classes. Example, a car class should inherit from vehicle, but not from building. Consistent naming conventions. class, method, and variable names should be meaningful and self-explanatory. Example: naming a class employee details is better than EDT 123. Logical object relationships. Objects should be related in a way that makes sense. Example: in a payroll system, an employee class should be associated with a salary class, not directly with company policies. Traceability to requirements. Every class, function, and interaction should be linked back to a user requirement. Behavioral consistency. Object states and transitions should be correctly modeled. Example: a user object should not be able to log in before registering in a system. These guidelines help in creating software that is structured, scalable, and error-free. Slide 4. Advantages of object-oriented testing. Finally, let's discuss some of the key advantages of object-oriented testing. 1. Encapsulation testing ensures private data members and methods remain protected from unauthorized access. Example: in a banking system, user passwords should not be accessible outside the user class. 2. Reusability testing tests inherited behaviors to verify if subclass methods work correctly. Example: a savings account class inheriting from bank account should correctly implement interest calculations. 3. Scalability and maintainability. Since object-oriented systems are modular, testing them is easier and more organized. Example: a large e-commerce system can be tested by dividing it into objects like cart, payment, and order. 4. Better defect detection. Since testing is performed at multiple levels, defects are caught early in the development cycle. 5. Efficient debugging. Object-oriented testing isolates errors at the class level, making debugging faster and more efficient. 6. Supports incremental development. Since OOP supports incremental development, testing can be done in phases. Example: in a school management system, testing can start with student and teacher modules before integrating exam management. 7. Improved code quality. Since testing enforces clean architecture and logical class design, the overall code quality improves. By following these testing techniques, object-oriented software becomes more reliable, maintainable, and scalable, ensuring long-term success.